Um, when you are dealing with an energy meter for single phase, the analog one will have something like this. So here it depends whether it's live, neutral, live. So it's what you have to test. So to see that, you can take it as like this. So we just have to test when you test here and here, and then you get, then when you test here and here, you get this test here and here. You get also this, just write it down, and then when you test here and here, when you get maybe above 0.2, that means you have your life to life here. If you test it here and here, you get 0.2, and then test here, you get another 0.2. That means you have live and neutral when you test here and here. So that means you have live. Because this tells you that they continuity. So inside the energy meter is like this. You have a current coil, and then you have also a voltage coil, a current coil, and a voltage coil. So a voltage coil is between live and neutral. So that means your life is, and then your neutral is here inside the energy meter. This is your energy meter. So inside there's a disc that is rotating continuously inside with an arrow here. So we determine the direction of current flow. So you have your supply side and your load side. You have a supply side and a load side. It's an input, output. So if you connect it wrong direction, the will tell you reverse in this direction. So the reason for current coil and a voltage coil is because we measure the power in voltage times current. So This one is determining the voltage, this one is determining the current. So this is the product of voltage and current. It's in kilowatts, so the time that is taken. So this one, because the combination of current and voltage, that's why we use a voltage coil and current coil to determine the energy meter. So when you are dealing with a three-phase, so this one is for a single phase. So if you're going to use a three-phase, if you're going to use a three-phase on this one, you are going to have 3 single phase energy meter. The reason for energy meter is that because we want to calculate the power consumed per hour, so we're able to pay the energy consumed. So one is for red phase because it's 3-phase, then one for yellow or white phase, and then one is for blue phase if you are doing a 3-phase. But if you're single phase, just use one energy meter. So the connection of the energy meter is this one. So as you can see from here, after connecting, you have to calculate the current. So this is a current coil, voltage coil, load side and the supply side. So when you're going to wire and draw this one, it's like this. This is a 3-phase energy meter. So you have, this is your main circuit breaker supply, your neutral link, the energy meter. It's like this. This is one phase, single phase. 3 single phase are used for this one. So what you do, the energy meter acts as a bridge, so it measures the current that is being consumed by the load. So that's why you take it to your live entering here, and then the output is going into this is the 8 leakage. So each line goes through, and when it comes, it goes to the 8 leakage. And also this one, when it goes, enter the energy meter and then goes to the 8 leakage. Also here, go to the 8 leakage. So as you can see from the neutral here, you loop all the neutral of the input, and then your output you also loop, but you take one to the 8 leakage. Your 8 leakage is this one. Then here, this is the control of this load. So your contactor is this one. your contactor. This is the contactor. So you connect it to a timer. This is a timer. These are the 2 circuit breaker that you see this side. So one is for the live and one is for neutral, and then loop the neutral from the earth leakage, then take it back to the neutral at energy meter. So the load side, you loop it and take it to the earth leakage, and the other neutral circuit breaker. This is the light that you use to show that energy is being consumed. Here you can put any load that you want. See that you put motor, stove, any 3-phase load that you want it, and then you take back to neutral. Then this contact is controlled by this circuit. So this is the control circuit of this one. Then 13 and 14 is for, it's linked to this one, and also linked to this one. You'll find the 13 and 14 on the contactor, and then you'll find your A1, A2 on your contactor. This is one thing. And then from 14 we'll take it to the light, and then the light back to. So when you close here, your time is automatically energized. So the contactor, it will wait for a time to count. After finishing counting, it goes through, closes. When it closes, the contactor energizes and closes. So the light will come on, then this contactor is closed, then your energy, your load will be supplied, the energy will be start to consume. So the moment this light comes on, that means check your energy meter. The wheel will be moving in this direction, the direction that is shown in the energy meters. So if it's moving in the other direction, then you have to swap your input and the output. That means it's consuming in the other direction, so you have to swap these two. Check which one is rotating the right direction. So if one of them is not rotating in the correct direction, just swap these two. It will be okay. It will move, but it moves slowly. You have to check it. And other than that, that's it.